Hey folks, hacking this and that, back again with another video. This time I want to talk about data logging, and specifically some applications of data logging with sensor design. And I will get into some sensor application, but I wanted to just sort of wander back through history a little. And many of you know that I've been involved in GPS tracking at various levels. It's now just more of a hobby. Um, for probably about 20 years. I was around when the 3G rollout first started in North America. So back then, the cellular network was not all that different from the helium network is right now for coverage. You got these great concentrations in the urban areas, and then you got interstates and freeways that have little to no coverage. And the way the manufacturers decided to combat this problem was by introducing data logging functionality into the devices. So when it's out on the road, you get great coverage in the city, and then he's heading off to the next town, and there's no coverage on the interstate over to where he's headed. And once the vehicle came back into coverage, it would then upload that data. So that's evolved a little, obviously, with 4G and the evolution of sort of more and more data-friendly coverage. And they started shaving that out of devices like this. You can still find it in larger units that are designed for long haul going places where there is no coverage. And the concept is in GPS tracking for the cellular world is referred to as store and forward. So what the data logger basically allows you to do is, if there is no coverage, don't dump the data, don't lose the data. Store it into a buffer that can then be uploaded when it returns to coverage. Now, I see a lot of you in sensor dev working on your projects and so on, and I want to sort of emphasize the importance of this because it's not just for mobile assets. You could have a sensor that's in a fixed location that suddenly the hotspots around it are no longer working properly. It doesn't happen often, but if you've got a low coverage area and a centralized service like electrical that takes out an entire town, that data would end up being lost. One of the cool things that helium allows you to do is forward data on after the fact, because in a smart design, and I'm going to sort of give credit to Dragino here because they have since released, you've seen me talk a lot about the LHT65s, the LHT65N, new, whatever the N stands for, does have data logging capability. So how do you use that in helium? Well, if you turn around and take this device, put it into a mobile cold storage, whether it's grocery delivery, frozen food delivery, neat trick I saw, raw dog food delivery, if anybody's looking for a niche market they want to get into. And when this device is no longer in coverage, it will log the data. And then as soon as it is back into coverage area, it will upload that stored data. So how does that work? Traditionally, we're used to seeing in console these uplinks occurring at the preset time interval. So for this particular one, it happens to be 20-minute upload. For this one, I have done some reconfiguration, and I now have it looking for an acknowledgement. That acknowledgement is the trigger that determines whether or not that data is cleared from the buffer or if it's logged. So how do you go about doing that? There are a few things that you need to do, and we're going to start with the documentation. In the documentation, there are a number of things that we need to be conscious of. The first is system time. Because this sensor is going to be passing its own internal date timestamp with the data, when you get it, whether it's an hour later, 3 hours later, you want to make sure you know what time that data was captured. So it's important to make sure we have the date time set. The network supports sync, which allows the device to request the date timestamp from the server and then synchronizes itself. So we want to make sure that sync mode is turned on. The other thing you may want to look at is the set time sync interval. How often do you want it to synchronize that time? Obviously, they're going to drift. It's just naturally happens. Whether you want sort of a higher resolution, more specific accuracy, if you're doing higher data samples, whether you set the default is set to 10 days, you may want to reduce that to daily or weekly or something else. Now, when you are connected to the device, you will find that there is a data point buffer. This allows you to access the recently captured data, but this isn't the same buffer. And you can pull it down by page, or you can pull it down by specific record, and you can clear that buffer. So let me quickly get this connected and make sure my console or my PuTTY terminal is going to connect. And I will walk you through this. So, how are we going to do this? Let's put this over here. That way I can still see the documentation. Okay, so there you can see my uplink activity. So I know I'm connected, and enter a password and AT plus, and I just messed this up. Again, reminder, when the documentation shows capital letters, it is case sensitive. So here's my config. And we're looking at sync mode. So we know that my sync mode is turned on. My sync interval, 10 days. And I have current date and time in mind. If you have a new device that you've just added to the network, it may not get the timestamp properly on its first request. So how do you do that? Well, let's scroll back up here to the set time. You can go to this Epoch website and get the current Epoch time and AT plus timestamp equals paste, and you get an OK. So now my device has the current time. Let me flip back over to my documentation. We knew that sync mode was on, and we knew that it was 10-day. I'm going to skip over the printing buffer stuff because that's really not applicable here, but I just wanted to show that it was available. And now we've got this auto send no ACK message. So how this works is if the sensor does not receive that acknowledgement message, it is going to store the payload in the buffer. My goal here, because I don't have a Faraday cage, I have a couple of electrical boxes. I'm going to put that sensor into this, wrap it in tin tape and tin foil, and then ground it out, and hopefully that's going to give me the same effect. We'll know in a couple of hours, and with the magic of video editing, for you it'll just be a couple of seconds. Anyway, so what I need to do here is AT plus PNG ACKMD equals 1. So I've now turned on the data buffer. If I flip over to, yeah, there's something weird about these newer versions. The ACT button doesn't seem to do anything while it's plugged into serial port. So, first thing I'm going to do is open this up. And confirm oh, that did upload as expected. So, no, it did not upload as expected. Another funky thing I find with these new ones is it takes a little time for it to realize that it's not connected to a serial port. So I'm just going to pop the battery, put the battery back in, and I should see an uplink and an acknowledgement. Okay. There we go. So now nothing has changed on the console. It's just the configuration in the sensor. So now that I have enabled the data logger, I'm going to take a break, go put this in my homemade Faraday cage, and come back and show you how it's going to receive that data log data once it has coverage again. All right, so it seems I wasn't as quick as I thought I was going to be. If you look carefully, you'll notice that the time interval has jumped from 540. So this is my homemade Faraday cage, and it did work until I removed the ground, in which case then it just became an obstruction. But you see all of those events starting to come through and their acknowledgements, and that is the sensor starting to upload those logged events. So give me a brief second here while I make a whole bunch of noise. This is proving to be more difficult to get into than I anticipated. A couple layers of tin tape in and of itself didn't seem to do much for RF dampening, thus the wrapped in tinfoil that I had to add there. You can tell that all of this is unscripted. Otherwise, it would have been like one of those cooking shows where I would have just reached under the counter and pulled out a sensor and done ta-da, which obviously isn't going to work. Anyway, the point being, this sensor was removed from access to the network, and now we're seeing a significant flood of data starting to come through, which is good. This is the data logger doing its job. Now, what happens to that data? Well, I'm going to cover that in just a brief moment. So here we are. I want to give it a moment out in the air to attempt to upload all of its buffered data. If I have a quick peek here, I can see that the payload is normal size. So it is literally just going to replay the events that it had in the buffer. Sorry, in the data log, not the buffer. There is a difference. So what happens with this? In my instance, I am feeding all of this into an application that I developed using Node-RED and InfluxDB and Grafana. There's a future video coming where I'm going to dig deeper into that, but you're going to get a sneak peek sort of under the covers of what that looks like. So what I have done here is over here on my API endpoint, my data comes in, it gets sorted as to which of these other flows it follows. It hits the switch and says, oh, that's for an LHT65N, comes up to this function, messes around with my payload a little, and then I'm hitting this debugger, which is going to give me my data that I want to show you. Oh, I'm getting errors. Maybe my program isn't working as well as I thought it was. Temperature undefined. That's the same sensor, number 9. But it is hitting my debug, and that's number 9. Which means if I was working on a different computer than this one, I'd be able to log into my database and show you the records that are supposed to be getting inserted. But I suspect this node here that's throwing the errors is telling me that it couldn't insert that record into the database. But the important thing I want to show you here is this reported at. So if I have a quick toggle back over to my epoch time, 166, 11, 23, 414. 11, 23, 11, 23, 429. 11, 23, that value is slightly different, as in there's a higher resolution. So hopefully I can figure that out and include a comment as to why that was. But my point being is that is going to be the reference time. Oh, I know why. Ignore that. This is my event time. Because if I scroll way down here, I'm going to see that my time is incrementing. So 297169. I'm wondering if these are coming in out of order. Possibly coming in out of, no. 707, 38. Yeah, I think they're coming in out of order. Anyway, when I get to covering the application and how it works and showing you in the database, I'll dig deeper into that and possibly why this was throwing an error. But as for the data logger, the test is successful. I've put together a sensor, turned it on, isolated it from the network, brought it back into the network, and you can now see all of the message payloads being uploaded, which is exactly what I was hoping to show you all. So for now, I'm going to come back over here, briefly pull up that console. Nope, that's the wrong console. That's the other sensors. So we're at 7:10, currently 7:12, so we are now back into our regularly scheduled cycle. So if I grab my sensor and I force an uplink, love the magical, not long enough, but felt too long. There we go. Force an uplink. And there we go. So we're back into regularly delivered message cycle. So that's all I wanted to show you for now. Again, later on, I do have another video coming where I'm going to dig deeper into that Node-RED application, and I will circle back to how to process the logged data events from the data logger, as that's a particular application that I see useful, as I said, whether it's grocery deliveries, frozen meat delivery, frozen dog food delivery, where you're going to have a moving asset that can go into areas that do not have sufficient coverage, that you want to capture that data and still have it for logging purposes. That's how you can do that. Not all devices do that, which is sort of the other lesson out of this. Is if you are developing your own sensor device, please consider adding data logging functionality. As I said, it's been around for a while in GPS trackers from the 3G, 4G era, and I think it's time that the LoRaWAN sensors come to a point of maturity in this feature and then start including that in their design. So that's all for now. Again, this is Hacking This and That. You can find me on the Discords. You got questions, ideas, just want to bounce anything off of me, feel free. And I'll see you